In today's video, let's explore the topics of right triangles and trigonometry. So first, let's define what a right triangle is. A right triangle is a triangle in which one of the interior angles is equal to 90 degrees. The longest side of the right triangle, which is also the side opposite to the right angle, is the hypotenuse, which is denoted as the letter C. The sides adjacent to the right angle are known as the legs of the triangle, represented as lowercase a and b. The general notation for labeling a triangle is to use lowercase letters for the sides and capital letters for the angles, and we typically have the sides opposite to their corresponding angle. So for example, side A is opposite to angle A and adjacent to angle B, while side B is opposite to angle B and adjacent to angle A. We should also understand that there's a relationship between the three sides of a right triangle. This relationship is known as the Pythagorean theorem, and it's a really important topic in geometry. Essentially, it states that the square of the hypotenuse is equal to the sum of the squares of the other two legs of the triangle. And this relationship can be written mathematically in the form of a squared plus b squared equals c squared. Now that we understand what a right triangle is, we're ready to do some trigonometry. In trigonometry, there's this very helpful expression, SOHCAHTOA, and it's a mnemonic device that helps us remember the three most common trig ratios: sine, cosine, and tangent. So the first part, SO, tells us that the sine of some angle theta is equal to the opposite side divided by the hypotenuse. The second part, CA, tells us that the cosine of theta is equal to the adjacent side divided by the hypotenuse. And the last part, TOA, tells us that the tangent ratio of theta is equal to the opposite side divided by the adjacent side. The terms opposite side and adjacent side should make more sense in an example. So let's say we have this right triangle, and notice it has a 90-degree angle, and we assign an angle with the letter theta. The opposite side of theta would represent this leg of the triangle. The adjacent side of angle theta would be this side because it's right next to the angle, and the hypotenuse is always opposite to the right angle. It's important to note that the terms opposite and adjacent are completely relative to the angle we choose to focus on. So if I choose to focus on this angle x, for example, the opposite of angle x would now be this side of the triangle, and the adjacent of angle x is now this leg of the triangle. But again, the hypotenuse is always opposite to the right angle, so that stays the same. Let's take a look at an actual problem where we can use these trig ratios. So let's say we have a right triangle and it has side lengths of 3, 4, and 5, and we have this angle theta. So the question is, what is sine theta, cosine theta, and tangent theta based on this triangle? To solve this problem, we first have to identify the sides that are opposite and adjacent to angle theta. We can see that 4 is adjacent to or next to angle theta, and 3 is opposite to angle theta, and 5 is the hypotenuse because it is across our 90-degree angle. Now, this is where our mnemonic device SOHCAHTOA can help us. Since we're looking for the sine of angle theta, we can see from the SO portion that sine theta is equal to the opposite divided by the hypotenuse. So the side length opposite to theta for this triangle is 3, and our hypotenuse is 5. So if we plug in our values, we should get sine theta equals 3 over 5. Let's apply this same concept to find the cosine of theta for this triangle. Again, we can use the SOHCAHTOA expression to see that the cosine of angle theta is equal to the adjacent divided by the hypotenuse. So the adjacent side to angle theta is 4 and our hypotenuse is 5. So if we plug in our values, we should get cosine theta is equal to 4 over 5. Now for tangent theta, we can use the TOA portion of our mnemonic device to see that the tangent of angle theta is equal to the opposite divided by the adjacent. The opposite leg of angle theta is 3, and the adjacent leg to angle theta is 4. Again, we just plug in our values and we should get tangent theta equals 3 over 4. So I hope you can see that the procedure for solving these problems are relatively straightforward and that our mnemonic device really does come in handy. Let's try another question together. Assume we're given a triangle with side lengths 5 and 12, and they assign theta to this angle of the triangle. Now the question is, what is sine theta, cosine theta, and tangent theta based on this triangle? I will point out that we are missing, or at least not given, an important detail to solving this question. Can you identify what that important detail is? If you set the hypotenuse, then great job, because we need to know what the length of the hypotenuse is in order to solve for some of the trigonometric ratios. So our first step should be to solve for the hypotenuse, and to do that, we can use the Pythagorean equation. The side lengths a and b are equal to 5 and 12 respectively. so we can just plug them into our equation to solve for the hypotenuse. 5 squared equals 25, and 12 squared equals 144. If we add these terms together, we should get 169. And finally, we square root both sides to find that the hypotenuse of this triangle is 13. Now that we've solved for the hypotenuse, let's identify the sides that are opposite and adjacent to angle theta. If we dial in on angle theta, we should see that the side adjacent to or next to angle theta is 5, and the side opposite to angle theta is 12. Okay, so now that we've identified all the side lengths of this triangle, we can find the trig ratios for angle theta. Let's first solve for sine theta. Using our mnemonic, we should see that the sine of an angle is equal to the opposite over the hypotenuse. So the opposite of angle theta is 12 and the hypotenuse is 13. If we plug in our values, we should get sine theta equals 12 over 13. The next trig ratio to find is the cosine of theta. And by looking at our mnemonic device, we should see that the cosine of an angle is equal to the adjacent divided by the hypotenuse. The adjacent of angle theta for this triangle is 5 and the hypotenuse is 13. If we plug in our values, we should get cosine theta equals 5 over 13. The last trig ratio to find is tan of theta. Using our mnemonic, we can see that the tangent of an angle is equal to the opposite over the adjacent. Again, the adjacent of angle theta for this triangle is 5 and the opposite of angle theta is 12. Now we can divide 12 by 5 to get our final answer, tangent theta equals 12 over 5. Here's a problem you can try on your own. Pause the video to see if you can find the answer. The first step to solve this problem is to find the missing hypotenuse length. So let's set up the Pythagorean equation a squared plus b squared equals c squared. The side lengths for this triangle are 7 and 24, so let's plug these values in for a and b and solve for c. 7 squared equals 49 and 24 squared equals 576. Add these two terms to get 625. Square root both sides to get the hypotenuse length 25. Now that we have the hypotenuse, let's identify the sides that are opposite and adjacent to angle x. The side adjacent or next to angle x is 7 and the side opposite to angle x is 24. With all the triangle lengths identified, let's find the first trig ratio, sine x. The sine of angle x is equal to the opposite over hypotenuse, so let's plug in our length values and we should get sine x equals 24 over 25. Now let's find the cosine of angle x. The trig function cosine is just equal to the adjacent over the hypotenuse. Same idea here, we can just plug in our length values and here we should get cosine x equals 7 over 25. Lastly, we have our tangent function. The tangent of an angle is equal to the opposite over the adjacent. Again, we can just plug in the corresponding side lengths and we should get tan x equals 24 over 7. Today, we learned how to define right triangles and briefly reviewed the Pythagorean theorem. We learned a useful mnemonic device that helps us remember the definitions of the three most common trigonometric functions, sine, cosine, and tangent. We also learned how to identify side lengths that are adjacent to or opposite to a particular angle. If you have any questions, please feel free to leave them in the comment section below and I will do my best to answer them. That's it for today. I hope this was helpful and I will see you in the next one.